All right. I think we are live. Finally, the day has come. All right. So first of all, I would just like somebody to please write in the chat that you can hear and see me, so that I'm not talking to just myself. All right. Good. Thank you. So this is live presentation, not pre-recording. And I would like to first of all say welcome to this first day of Sweco's 4 longer sessions here. And the agenda you can see here on the presentation here. But I would like to introduce myself first. My name is Mikael Månsson, and I work at Sweco with FME. And I hope you have had some great welfare days before this, and you gathered a lot of inspirations for upcoming FME usage. So I would like first to say some words about what we do at Sweco. With our clients and almost 18,000 colleagues, architects, engineers, developers, and other specialists, we co-create solutions that address urbanization, capture the power of digitalization, and make our societies more sustainable. So we offer our clients the combination of global expertise and local understanding. So with more than 35 FME certified specialists, with many of us with multiple certifications as well, you can always feel safe that we can help you with your local problem. So with that said, I would like to welcome our friend Jonathan Maidens from the European Environment Agency and my colleague Ulf Månsson to the stage. And while we are switching screens and unmuting and stuff like that, I would also like to address the way we will handle incoming questions during the sessions here. So you can either send your questions to Josephine Axelsson straight through direct message in Zoom, or if you prefer, you can also use the raise hand function for question via video. And then we will after each presentation, we will arrange the question and answers then. Yeah. So with that said, please take the stage, Jonathan and Ulf, and I hope you have a great experience with this presentation coming here. So thank you all.
Thank you very much, Michael. First checking, does the PowerPoint slides look okay in Zoom? I'm no Zoom expert, so.
It does.
It does, great. So we are going to talk about something called Reportnet 3. And Jonathan here is going to help explain what EEA, or the European Environment Agency, does, and how Reportnet 3 plays an important role in that. And there's a lot of FME involved in all this. So we look pretty young here, don't we, Jonathan? it's yeah. So but Jonathan is I think you said data flow manager. That's a good title. Fits very well with FME welfare, because everyone works with data. That's what we do. And I'm Ulf Månsson. If you don't know me, I'm what do you say, old FME nerd, been working with FME for quite a long time. So, and we have a agenda here, how this presentation is set up. So first, Jonathan here is going to talk about the European Environment Agency shortly, to describe what you do and a bit what we help out with. But there are massive amounts of data, that's for sure. And explain a bit about what Reportnet 3 is. And then we're going to talk about this reader We're working with developing a reader for this Reportnet 3, and probably later a writer as well. So we've done some prototyping for that. So we're going to explain how that worked, and also a bit about dynamic writing, which is yeah, maybe it's an advanced topic, but it's something that is really good to learn when you work with FME, as it can save potentially a lot of time. And we are also talking a bit about the future towards the end, where we're actually working on a more efficient reader, a real reader, if you say so, in FME. And the aim is to put that in the FME hub. So this is the setup for the presentation. And so then you're good to go, Jonathan. I guess you have to say beep or something like that when I switch.
Okay.
So
then let's go to the first slide. Thanks. So
yeah.
Good morning, everyone. My name is Jonathan Maidens. I'm in the data management group at the European Environment Agency. It's a pleasure to be here and to be able to share some of our work with you all. So I have four slides where I just want to give you a context of our e-reporting platform of Reportnet 3 before we move into more technical discussion through Ulf. So the European Environment Agency, in short, we work with the state and trend of Europe's environment, publishing information which is directed at public awareness and policy change. And we do this through, there's two different ways that we have to support us in this. The first is that we are very strongly networked, with the European institutions, but also with universities, research, and the private sector as well. So we use a very strong network of throughout the countries of Europe to build up this picture of the state and trend of the Europe's environment. The other aspect that we have is the flow of information, the information that we can use to gather, that comes to us, that we're able to make, to analyze and produce assessments, etc., on the state and trend of Europe environment. And that data comes to us through either voluntary means. Our network is very long, 20 years, more than 20 years established. So that data comes to us through the voluntary, but also through legislation, through EU directives, and also through broader conventions as well. So if you can please go to the next slide, Ulf.
There we go.
So when I talk about data, it's very broad, environment data, and all these sectors, we are involved in all these sectors that you can see on the screen now. And the nature of the data is very different. So I can talk about air pollution, and that might be near real-time air quality data. We have noise maps around roads and railways and airports. Financial information on climate change impacts. We also use information on river basin management plans, programs of measures to improve that information. We also have time series data on water quality, for example, on bathing water. So there's a huge variation in not just the sectors of data that we deal with, but also the types of data that we have. And they can come to us at different rates as well. I talked about near real time, but we also have a lot of it's annual data, but also can be every 6 years. And it can vary from like a few megabytes to gigabytes of data as well. So we have this broad spectrum of data. Next slide, please. And that data comes to us typically through country deliveries. We have an agreement. This is the data. This is how it should be delivered. It comes to us, the European Environment Agency, and then we create a European data set. And then on top of that, European products are built. It could be a report. It could be an online electronic dashboard. It could be a lot of map-based map services. Data that we publish the product itself, or for reuse in other products that people want to build on top of that. And the way that this flow is changing, and it's changing a lot recently, partly because of this wealth of information, additional information that's available, but also the need to compress this time that when data's become available, that it's already available very quickly in the products. We are increasingly having the number of data flows is increasing, so we need to deal with that. There's also new ways of working, like Copernicus data, satellite information, that needs to also be brought into the equation. New types of data flows, citizen science, for example, that's a new type of data flow, which is, which we can see is going to be changing the way that this flow of information happens. And also the use of new technologies. So using the machine learning for gap filling on our European data sets, and all the different ways that we can then process and publish that information. So we have to manage this broad range of data, and we have to manage the flow of that information in a way that is cost effective to us. But we also have to make sure that not only are we able to manage what the situation is now, but look ahead for the next 10 years. So to do that, we have the tool to help us do that is our e-reporting platform, which is called Reportnet 3. You go to the next slide, please. So this tool, what you see here is a very high-level functional view of our tool. So this is the tool that we have, our e-reporting platform, which we use to support this data flow. It's split into 3 buckets, 3 pillars here. On the left is the design. So it's a single platform that allows us firstly to design a data flow, figure out the schema, what's the tables, the fields on those tables, the quality control checks that will be performed on the data. And then once we publish that data flow out to our reporters, the countries, then they're able to deliver the data, add data to that data flow and supply it to us. And on the column on the right, this is where we're monitoring those data flows. What's the status, who's delivered, what's the quality of the data that's delivered, and then enables us to create the EU data set and then move that data out of the platform for more detailed processing. We have a common workspace, we call it, which has our Tableau and our ArcGIS tools in there for making the products, the downstream products I spoke of. So we have this. But this is what we have here is the standardization as much as we can of the data flow process. But as I mentioned, a broad range of data, the different data types, the different frequency of that data that delivered to us. There's certain elements, and I've highlighted these in red. And this is where the integration really is with FME. That's where we use it a lot, because a different data flow, with different data type, a lot of transformation is involved. And also with the machine-to-machine the system-to-system integration, which we really want to push now with this reporting platform, in that we are able to take delivery of data through APIs. There's an API on top of Reportnet 3, and also harvesting data from services. We want to give more options for the reporters, for the countries, to be able to deliver the data up for us, and for us to be able to connect to the data, to enable this flow of data to make it much more easier. So those two areas are very much where we see tools such as FME. We widely use them, and also where we can see we can provide more support to the countries in providing tools for their own system, so they can do their own transformations of their own data to push it into Reportnet 3. So I hope that gives you some context of where Reportnet 3, the e-reporting platform, fits into the flow of information. And now I think I'll hand over to Ulf, who can take it into a more technical level.
Yeah, thank you very much, Jonathan. Very informative. And one thing I tend to forget sometimes is it's not only the EU we talk about when you collect data. It's actually it's better to say Europe, I think. Is that correct?
And beyond. I mean, yeah, Europe. I mean, we have our EEA institutions is broader than the EU, and we also have some of the conventions data coming from countries outside of Europe, Russia, for instance, in the southern Mediterranean.
Yeah, it's really exciting to work with you in this, because there are so many different types of data from so many countries and so on, and it's really for an important issue as the environment as well. So it's really exciting. So as Jonathan mentioned, there is a lot of FME being used at EA, but we're going to focus on this part then, which is, as Jonathan mentioned, on this Reportnet 3, which is a pretty new thing, and it's under development, as I understand it. And there is an API sitting on top of that already. So how because you get data in there, and it would be easier if we had a reader to read that data. And it can be in different phases and different stages and so on. But as there already is an API, we have done some prototyping for this. And we started out with this simple workflow. What we did was custom transformer, which is the one, the Reportnet 3 reader down there. And that one, yeah, it looks like this. And this is how you kind of navigate. There are a few different naming conventions in Reportnet 3, data flows, data set, and tables, and so on. And there's an API key you can enter here to get the whole of the data you need. And if we set it up like this, this custom transformer gets the schema out, and it turns that to FME schema features like this, and then you get the actual data records. And we sent this to a regular writer, but in dynamic mode. And if you haven't used this method before, I would really recommend you to look at the documentation and the knowledge base and so on, how this works, because it's pretty cool. Because when we set up this workflow, we can go to any kind of format. So the data comes as JSON in the API, JSON and GeoJSON for the geometries. And then when we have this set up, we can select to write this to pretty much anything automatically, like Microsoft Excel or even a text file, or yeah, you name it. It can be a bit tricky to set this up, but the key is to learn about schema features in FME. And the way it works in this prototype is that one part of this custom transformer, it queries the REST API. Give me the schema. It says, give me the schema in JSON format for the tables we are going to read. And the answer looks something like this. This is the reply in JSON. It describes the field name and the field type. It also has a data type here, but these data types are Reportnet 3 data types. And luckily, this structure is looking pretty much like the official FME schema features. So what this part here does, it transforms this structure to the right structure here. But that says FME data type name, FME data type name, and it also sets the geometry as it comes in GeoJSON in here. So I don't know if that was lucky or the API was actually built in mind for this, but it works very well. So that is one part. And here is my first tip, dynamic workflow tutorial. You have that in the FME knowledge page. There is a good, there are a few good articles, but dynamic workflows in here. And I would say it's among the most time-saving features in FME. So that was the first part, getting the schema in this prototype. The second part queries the actual data for the tables. And the data is returned in a slightly different structure. It comes like, I think you could say key value store. I say it's more like a cell value structure. That is, you get a record for each column or something like that. I think you could say like this. But what we do in this part is we aggregate, you could say like a pivot table in Excel or something like that. But we aggregate these so we get a tabular formation of this. So you get a table out there. So that comes through the data port. And then by combining this data, so now that is formed in a way that FME likes a table structure, and we got the schema structure on the other part, and we can route this to the dynamic writer. So this was our first data type. I should mention, if we go back here, that there are quite a few native Reportnet 3 data types that we experimented with mapping. So something like a integer, that's pretty straightforward to map to a relevant data type in FME, but you could always argue how to map text and text area, for instance, or an email here. So there are quite a lot of mapping to do, but not super complicated though. So we tested this, and this works. Yeah, it works very well. It's easy and quick to set up. So we try this as a custom transformer and possibly also as a custom format. I don't know if you have tried creating a custom format. That is when you have a workspace, you can save that and it becomes a reader if it's set up in the correct way. And that, I would say, for EEA internal purposes, this would probably be good enough because it gives it's pretty flexible use, as you can write to any format. You don't have to do the querying on the API by yourself, figure that out. So you can save this as a custom format or a transformer. But as the goal here is to make things easier, not only internally at EEA, but even for other countries using the Reportnet 3 platform. The goal here is to put a very usable reader function in FME hub. And there is a challenge. If you just use this custom format, custom transformers, it's kind of hard to make a browsable data set for the parameters. And with that, I mean that when you add the reader and you add your API key and stuff like that and log in, you would like to browse through something like Windows Explorer or something like that to find the correct table to make this user-friendly. And those kinds of operations is kind of hard to in a custom format that you do just out of the box in FME. So and to get this really usable, it should be really user friendly. But I also encourage people to check out trying this, creating a custom format can be very useful in many situations. For instance, if you have a reoccurring situation where maybe you read a GPS log or something like that that has a special structure, it can be a great idea to save that workspace as a custom format to make it easy to be reusable. So what do you do in this case to get it user friendly? Well, that's we should break out to some Beatles singing here, Jonathan, but maybe I should spare you with a little help from my friends. So you ask Safe Software for help, and my colleague Peter Segerstedt, of course, who's kind of a I would call him. I know I'm not bad at FME, but he's kind of on another level in the details here. So he has been experimenting with FME and Python packages already, and knows the way around here. And we got some help from Safe to set up a FME package. At least the base for this as a template. So this is what we are working on now to create a more user-friendly and possibly even faster reader for this. So I'm going to try to show how this looks in these early stages, and thanks much to Safe Software's help. So I'm going to try to play on video here and see if the video gods are with us. Okay, maybe I should start like that. Okay, so this is how you get this package and you install it. Remember, this is just the framework that we are getting running, so we kind of port in the functionality in the prototype you have. So you add a web connection. That comes from the package itself. So you add that and you put in your API key, and it works like a regular web connection in FME. And then you can add a reader for this. And here is very much the key. So now you can go to parameters, go to the connector, and you can browse online. So now it's really talking about with the Reportnet 3 platform and lists what I have in there. And I can browse down there and find a table there. So it's like a 3-level set here. So, and here is my point test there. So I can add this reader like this. And this is pretty hard to do if you don't do something like this. Maybe there is something coming for this. I know there is a lot of new features when editing parameters. You can make better and better GUIs out of the box in here. But to make this really usable, I think this is probably the way to go now. And as I said, this is just a skeleton now. So we're adding more and more functionality. And I don't think we dare to mention a time frame when it's in a first version is in FME Hub, but I think it should be fairly soon. And that is much thanks to the API that I think is very cleverly constructed, which makes it easy to do these kinds of integrations. So let's see. We're pretty much in the end here. And I think we have a few minutes, like 3 minutes left here, if there are any questions. Michael, do we get some help with scanning the chat for a question? Because I can't find the chat window now.
Yeah,
I'm no Zoom expert.
Me and Josephine are moderating the questions, so we have some for you here, actually.
Yep. Shoot.
First, I got one question here about validating data. I think it's before publishing stuff. If there are any plans of Transformer for validating data to be able to publish to this?
Yeah, I think so, but correct me if I'm wrong, Jonathan. When you define the schema, you actually define quality checks in the platform, isn't that correct?
No, we do indeed. There's a very comprehensive validation engine which sits behind the for when the report delivers the data. So we define all the QC checks, and they can be very simple, a field type, making sure it's an integer, but we also have, we can also do the underlying database of Reportnet 3 is Postgres and PostGIS, so we can actually expose all the spatial functions that PostGIS has as part of our validation. So we can actually do quite a comprehensive validation on the data for the reporter before they press that button saying deliver it to us.
I mean, we have had some early discussions, at least in theory. We could kind of pull those rules out to Transformer before, so you can have checks while you're running the FME workflow as well. It's kind of save some time before doing that. But there is already good checks built in, as Jonathan mentioned.
Great. And also got a question here. Did you also look into the schema setter Transformer to try to create a schema automatically without downloading the schema from the REST interface before?
I'm not really sure. The schema reader or the schema mapper? Which one?
The schema setter Transformer.
No, haven't looked at that one.
No.
Maybe I should. Maybe that solves everything.
Yeah. And also we got some interesting stuff here. If you want to be a creator of your own reader writer, you had some tips there with the knowledge article.
Yeah.
Do you think it would be possible to send that link out afterwards?
Oh, absolutely.
Yeah.
Just make a note, Michael, and remind me. So, and I can send some more links to good resources.
Do you have any other pro tips for or recommendations to create your own reader writer? within FME?
I think it would be interesting to experiment more. The custom format is kind of it's a bit forgotten, I think. It's not very often you think about using it, but it's an interesting thing. For instance, you can use it for you know, if you want a background map in the data inspector, you can make a custom format for that. So looking into that. And I also would like to see something in the new published parameter manager to do. It would be great if we could get some interactive functionality there, so you can make some, as I said, browsable data sources. And I think if people experiment more with that, it could make it clearer for SAFE that what would be useful.
Great. So if there isn't any more questions at the moment, no, then I will say big thank you to Jonathan and Ulf for this first presentations here. So
yeah, thank you.
Thank you. So now we will be directing our eyes to the west, at least my west, and to Norway.
Yep.
Ah, nice. I got muted, but you're with me. Good. So next presentation here will be from Roman and Sigbjørn, colleagues of mine in Sweco, Norway. You will be talking on the topic of efficient road design. Really looking forward to that. This presentation here. See if we can share the screen as well.
Let's try.
Yeah. Great. So the stage is yours, and the same is as for last question session here. Please use the direct message in Zoom to raise your question, or the reaction functions to raise up your hand and ask your question by video. So take it over, Sigbjørn and Roman.
Thanks. So yeah, we're gonna show off how to use FME to make road design and infrastructure projects more efficient. So it's kind of combining the GIS and the FME tools towards a specific kind of area, in this case, infrastructure. So I'm Sigbjørn, and I have my colleague here, Roman.
Yep. Hi, guys.
And let's see. Yeah. So today's attractions are 4 different cases, which are somewhat similar, but also somewhat different. So all of these are related to infrastructure projects. So the first case is how to automate the LiDAR data extraction, how to process it and distribute it to any software. So the common software we use it for in Sweco, Norway is the Navisworks, AutoCAD, NovaPoint. And for this automation, we use FME server because it's going to be run whenever me and Roman is sleeping also. So we don't want to be dependent on us. Also, we want to showcase how to work with terrain data and how to drape ortho photos to in infrastructure collaboration models. We're going to showcase on how to deliver the infrastructure data itself to different software. So between Autodesk, Lumion, and other software. So for this particular case, we used it to render 3D models, which looks more fancy than the engineering prototype in the engineering software. And at the end, we're going to show how to use photos in the real infrastructure models themselves.
Yep, sure.
I'm controlling, or you're controlling?
Sorry, I was just so excited. I just wanted to hear the next bit.
You want to skip me and just start ahead? Yeah. Well, I try to be before. So yeah. So the first case LiDAR data in Norway is easily available, but something being easily available doesn't mean it's easily consumable. And to use LiDAR data in any software isn't easy, especially for people that normally do something else. They're not used to working with terrain, or they're not used to working with LiDAR data. So getting the data is as easy as going to that URL in Norway. We're very lucky that way. It's free, it's available, and it's a lot of data. So we know that we can download it from that web page from the Norwegian Mapping Agency. And our case in the GIS department in Sweco, Norway, is to distribute all of this data to any of the 400 plus projects a year. And we have 1,700 employees, which are non-GIS people, that's gonna benefit from this software and from these data. And of course, we don't want to download just a copy of all of the data. We want to do it a bit smarter and only download the data we need. So the challenges are to get it automatically, because me and Roman also want to sleep during the night. We want to process huge amount of data because many of the projects are quite huge. And we want to figure out which format is best to deliver to each software and application. Because everyone has in Sweco has also the opportunity just to go to that web page and download, but then they only get the LiDAR data, and it's not self-explanatory for a non-GIS person how to use that data in the best way. So the biggest project we have been using this on is a project called E39 between two big cities, Mandal and Dingdal. It's 25 kilometers of roads and 30 gigabyte of compressed LiDAR files. And you can see on that web page a little bit more information on that project. And we run this procedure on that project. It took me 1 minute to order the data, specifying which coordinate system and uploading the project area, as you can see on the right there. And it took FME around 6, 7, 8 hours to order the data from the mapping portal, waiting for the data and converting the data to all the delivery formats. So input is, as we can see on the left here, like LiDAR data. Most data in Norway is classified already, so we're quite lucky. It's classified into different ground, buildings, and vegetation. And by using FME and FME server, we can deliver the raw terrain model on the right side for all the 400 plus projects a year, both big and small. So we have two workspaces doing this. The first one is downloading the data in our own FME server. So the user just have to draw a polygon and select the coordinate system and then wait for the data. So we have 5 major parts. We are using the polygon the user drew. We are doing some REST calls towards the API to download the data, similar to what we saw in the previous presentation. We create some metadata files and we download the LiDAR data themselves to the server. Looks kind of messy, but if you group it into different parts, it gets easier to understand. The second part is the processing of the data, because we only have raw LiDAR data. Still a bit messy, just to showcase that you don't have to be very strict about how you manage your workspaces. And we don't actually do a lot here. We just split the LiDAR files into ground and houses and vegetation. On number 2 here, we quite different resolution on the terrain. So for visualization and large areas, they usually want to work with a lower detailed model. But if they're doing more detailed modeling, they want to use the higher detailed model. So we give them 2 different models. And at the end, we give them the option to continue to work with the LiDAR data, the raw data, or they can work with the finished surface and terrain model in LandXML or DVG files. And depending on which profession receive these files in the project, they can choose what's best for them to work further on. So all of these files are being used in different ways. And the good thing about this is that we can take the LiDAR files. We can create the output on the screen there, the surface model. We can create the cleaned LiDAR files in the middle with only the ground points. And we can create a quality measure for that project polygon to let the user know that, okay, in the green areas, the LiDAR data is good and recent, while in the red areas, it's old and less quality data, so you might need to do a more survey. And creating all of these formats, you can put it into all of these applications and even more. We have 4 or 5 different very engineering software that also can handle these projects. So we can custom made deliverables to specific departments within Sweco.
All right. Sigbjørn was talking about how we process the terrain data, but what I'm going to show you is how we use that data for collaboration in infrastructure models. One of the largest challenge I have in my day-to-day work is that an infrastructure project is very unique depending on who is running it, and unique in more ways than I like. One of those ways is that which solution we can use to view the coordination model. So usually in infrastructure projects, we have several disciplines that do the roads, do the landscaping, do the water and sewers drainage, and we want to collect all that data that they project into a collective model that we can collaborate with, or that we usually do a big ICE meeting with Teams or Zoom, and we show the model and we look at problems that are there. And one of the challenges there is that we are struggling to get the most recent data that we can. And one of the solutions that we come up with is that when the project is starting construction, we usually have a agreement with the people that are constructing it that they can fly a drone about each week or once every other week, where we can get a grid of a lot of pictures of the recent situation, and we want to use those pictures in our coordination model. One of the challenges of doing that is that first, there are many different platform solutions for each project. So the workflow for creating those draped terrain models with orto photos, they are a little bit different for each project. So they are pretty hard to automate unless you're using FME, which I will talk about a little bit later in the presentation. But FME allows us to structure the workflow in such a way that it's virtually the same for each project, but the output that FME gives is the output that we want for each collaboration platform, whatever it requires. If it requires FBX or SketchUp file or any other format, FME can then produce that and make it easier for keeping up with updating the latest orthophoto publishings from the constructor. And another thing is that often we also wish to clip the terrain model so that the new solutions of road surfaces, they come through. And that is also a part of the FME structure that I will be talking about. So to summarize a little bit, the challenges we have with this case is that we need updated data very frequently and very fast, because you cannot use very much time on each update, because that costs time in project. And usually when the drone has flown the day before, we need the data in the model right away. The drone data, I will not go very much into it, but it's a similar workflow to what Sigbjørn has presented, that we can also generate the terrain through photogeometry. That's mostly for calculating masses and volumes that we use that for. But it's updating the orthophotos and clipping the terrain models for the updated road and landscaping models, because they are updated each week as well to accommodate the new findings, new situations, for if we discover that we have challenges technically for building the road. Yeah, and lastly, the different collaboration platforms, so how we solve that. So the solution is run it through FME, because the workflow is virtually the same, disregarding whatever type of file we get from as an input. We usually use LAN-XML, and this is the LAN-XML that Sigbjørn was talking about in the previous slide, that we get from either updated LiDAR data or updated drone photogrammetry data, and updated DVGs of the roads and landscaping models, or sometimes also EFCs for construction models. And we get the updated orthophotos, and those are run through the FME. I've chosen not to show the workspace, but I have it up on my computer. So if we get some time and people are interested, I can show off the workspace live afterwards. But what we get out after that is that we have a solid, fast solution, which requires minimal amount of manual work. It's mostly automated through FME and FME server, which takes the pictures that are published to SharePoint or other sharing platform that the constructor uses with us. And it processes the data when it registers that it's updated, and it's updated in the night. And the model is updated and ready for new meetings throughout the day or week. So both those models are on a web-based solution. So project participants can just log in and view the latest photos and latest clippings of their models, and make adjustments for that. That's what I was about to say on this part.
And just to add on the last part there, like the good thing about FME, as you show, that you can also clip the terrain with that data. So that's very, very handy to remove the terrain.
Yep.
So yeah, I've done something similar here. You're focusing on delivering the infrastructure data to the different portals we have. I've also worked with delivering the same kind of data to other expert software. So moving data when you make it in NovaPoint and moving it to Civil 3D or Naviswork. So between the different professions in a project. So how can it be easily accessible by everyone? And the answer, of course, is using FME. So the challenges which I'm going to highlight is that we are using a lot of different locations. So we're using project-wise, SharePoint, shared disk, email, and any other platform for storing and collaborating data. And as Roman mentioned, we want live data. I like to publish the work of someone to everyone else as fast as possible, because that makes it easier to use a collaboration model and also to make decisions. The tricky part about working with different professions which are non-GIS is different 3D geometry. It's more complex than using the regular point line and polygon that we're used to in the GIS world. So how do we move the data between SUSI, DVG, EFC, Revit, and all these different software and to all the different software? So it's a many-to-many, of course, by using FME and automating this flow. So for this case, I've highlighted 3 workspaces. So the first workspace is similar to the one we showed before. It focuses on getting the data. So either by using a shared network drive and reading the data there, or using one of the excellent connectors in FME, the SharePoint connector, the Autodesk BIM 360, or the ProjectWise connector. So think of these as a way to get data. So what we usually say in the project is that they get a specific folder to put the data which they want to be synchronized, and then we use that for reading and writing data with FME. That makes it easier than going to specific subfolders or certain folders to have one location to work on. That makes it also easier for us because it's up to the different people to put the data that they want to synchronize there. The second part is actually doing the stuff. So with the power of FME, we can read IFC, Revit, DVG, SUSI, and any other file. And we can sort out the different layers or features we need. And we can, of course, write out to any file again. So it's quite handy. And the last part is, of course, to deliver the data, not as a regular data download service on FME server, but we use the same approach as the first workspace to use the 3 connectors here and also the shared folders, and just upload that to a specific folder. So then they have live data in their own format that they want to. So for the end user, they don't need to open their software and import it anymore. They can just use the same file and they know it's updated. The challenge is also working with geometry, as I said. When working with IFC and complex DVG files, we usually have aggregates, which is a collection of objects. We have traits with attributes. We have line, we have extrusion, we have faces. So you have to get a bit more understanding on more complex geometries. But once you get over that by reading this BIM tutorial, then it's also much more fun to use FME with those newly objects. And then you can go from the engineering model to the left, which looks a bit like old software because it's old software, but it's good to calculating roads and bridges. And then you can go to the more Instagram friendly photo on the right side and actually sell this project to the inhabitants of the city and the municipality and say, well, this is going to look good at the end.
Yep. Lastly, I wanted to talk a little bit about inspection photos for projects, because one of the challenges that we have in the start of each and every project is that we always do an inspection of the area that we are gonna run the project in, or upgrading with new roads or refurbishing. Is that usually the project engineers, they go out and they take a lot of photos. And by a lot of photos, I mean at least 1,000 per engineer, because they are out there not one day, but several days just to inspect everything and make sure that everything is measured in. And as well, they also take the photos of those things. And one of the challenges is that those photos, they always live in a folder somewhere, or in SharePoint or in a project folder. And the structure of those photos is just a file. They are named sequentially, like photo 1, 2, 3, 4, non-descriptive. And they are really, really hard to use in the meetings, because they always, it goes something like this, that someone wants to discuss where a particular pipe is, or something like that. And some engineer says that they have a photo of it, but we cannot find it because it's buried beneath thousands of other photos, and we don't have time to sift through them in the meeting. So one of the ideas that one of our colleagues had is that we could actually put them out in directly into the coordination model as flags. And that way we can use the geospatial data that's on the photo. If you take a photo with a mobile phone, usually the GPS data is encoded in the metadata. So why not just take that photo, scale it appropriately, and create a flag out of it, and set it where the photo's GPS data says it was taken. You can also use do this for drone data, that it's not a scanning flight path, but just a regular flight path for taking pictures and taking an aerial shot of what's going on. So to summarize, the challenges that we are trying to solve here is that we have a lot of pictures when the engineers are going out to inspect the project area. And the pictures usually go unused because it's super hard to find what is what and where is where. And this small picture, zoomed in picture of a pipe, where that is exactly in project. And lastly, and most importantly, it should be easy to view those in a meeting to better decision making. So the solution is, of course, FME. We can then go from the left side here, just a bunch of files and pictures, to actually placing them out in the model and getting a clear view of what we're talking about. And those pictures are also clickable, so we can click on them and view the metadata that was stored on them, so we can also find the original file in the folder. But usually people don't bother with doing that. They just go into the model, view whatever they want to view a photo, because those photos, those drapings, textures are pretty high resolution or at almost no computational cost. So they are good enough to make a decision and then and there in the meeting. So that's this is a simple solution, I would say, to a huge problem that we had previously. That was it. That was what we were trying to present, and I see that we have 2 minutes for questions.
Pick the most difficult one. So
yeah, I will pick the most difficult one. I could start in some kind of chronological order here, because we started off with some LiDAR data. And we have got some question here. How do you make sure to get the latest LiDAR data from Høydata in any given area?
Yeah, so that's an easy question, because the Norwegian Mapping Agency have a very easily REST API. So we call it sending a polygon of the area we want to download, and then it gives a reply which projects are flown over this area, and then all the metadata basically. So it's quite easy to find that information.
Yeah, good. And we have a question here also regarding point clouds. When working with big data in point clouds, do you have any recommendations for transformer not to use? Is there any bottlenecks that we should avoid? You have
working with point cloud data.
Mm.
Well, I would say you have to be careful about the caching and just try to limit your area when you work with it. And as I shown on the slide, we use the tin generator from FME. But if you really want a good terrain model with break lines, for instance, I wouldn't recommend to use that tin generator because it's not detailed or controllable enough to be able to have good break lines, for instance. So yeah, you have to be aware of the limitations on the tin generator, for instance.
Good one. Question here. Have you tried cesium for Unreal? Could that be used alongside for inspection those photos?
Could you repeat the first part?
If you have tried cesium for Unreal. So no.
But
Also
that's definitely something I want to look into, probably.
Yeah, could be cool.
Yeah, so that's okay. So the different endpoints we have, as Roman mentioned, like we can't decide where to put the data. We just get like, okay, you put it in ArcGIS or you put it in Navisworks or you're going to use this viewer. So yeah, that viewer is also something that can be used. Yeah.
And we will now have a question from Dean. So there you should be unmuted as well.
Right. Can you hear me okay?
Yeah.
Yeah. So it's just yeah, great presentation. I was just curious about the item 1 on the one slide for the terrain workspace for processing the terrain LiDAR. So it looks like you have a bare earth process of, separating out the surface model from the terrain model. And I guess you have a custom transformer that helps split that out. I was curious if you use, I know Dimitri had an example where he used the point cloud expression evaluator to essentially bin the data, and then you get the, then with the point cloud merger reference output, you can take the max and the min value, essentially sorting the points. So I'm wondering if you use that trick or if you had any other tricks for the classification.
Yeah, for the classification we used, since we're like spoiled in Norway, like everything is usually classified. So we can use just looking on the classification itself. For those LiDAR, for instance, drone photos are not as often classified. But the problem there is usually it's like steep areas, so it's difficult to say, okay, within a certain Z range, we have a terrain, etc. So we usually have to have it into another software anyway, because yeah, we're not Norway is not Denmark, so it's a bit deeper than that. So and yeah, usually we have to combine the data and do some manual work anyway. So then I leave it to another department to do that.
And I was just curious about the resolution for the national data set. So I noticed that, okay, the three resolutions that you have in the output are some of those like meter level, and then some are decimeter. What's sort of the typical resolutions that you're working with?
For the end product on these, like internally, or?
Well, I was thinking both on the input from the national data set for those large compressed files, like the 30 gigabyte 30 gigabyte compressed or 300 gigabyte uncompressed. So is that national data set? I was curious what the resolution was there. And then on your outputs, you said there's 3 resolution on the outputs of this workspace you're showing now.
Yeah, so for this one, it's the tin generator with 0.1 and also with 1 meter, and also an unfiltered one. Yeah, usually the problem is getting this data within the applications themselves. So we have to tile it or make the area smaller. So it's usually way too much data. But by using, you can also download a pre-made terrain model, but that's usually a lower quality one than the one you make with FME, because you can have a higher resolution using the LiDAR points and using FME.
So is that what you would use land? I'm curious what you use land XML for. That's both on the input and the output side, land XML?
Only the output. So the input is always LiDAR.
Yeah, okay. And I guess, you know, like Civil 3D and other tools might like the land XML. That's why you have that?
Yeah. And also then the Nova point is handling the land XML quite good. And the civil, yeah, we have to have a workaround, so it creates a good land XML for civil. And yeah, the DVG is for the AutoCAD and yeah.
Okay, great. Yeah, thanks. No, thanks for that talk.
And thank you, Dean, for your questions as well.
Right.
Okay, I have a lot of questions for you guys, mostly concerning SOSI, but that's will be for another day. But I'm also a bit worried here. Straight lines, what's up? Come on.
Well, you don't need anything else until they get the hexagon lines. Then I'm gonna switch.
Thank you so much, Roman and Sigbjörn, for this presentation. All right, so from above ground infrastructure, we will now dig deep, or rather drill. Isn't that the way to go, Ulf?
Yeah, I think that's correct.
Yeah, so I would like to introduce Ulf Brising, certified FME colleague to us here at Sweco, and all around nice guy, I would say.
Okay, thank you very much.
So the stage is yours, and as in previous presentations here, please use the chat functions to raise questions to Josephine or to me, or if you would like to ask the question by video, use the reaction and hand raise function there. So take it over, Ulf.
Okay, good. I hope you can see my screen here, the presentation. And my pointer. Okay. My name is Ulf Brising. I'm a consultant at Sweco in Sweden, and I'm mostly working as a data manager in large infrastructure projects. And in this case, as Michael said, I will present a specific FME solution from the metro extension in Stockholm. This is me. And this example is about controlling and monitoring the grouting process when we are building tunnels. And I should also mention that this solution is one out of many FME solutions that we are using in this project. But the reason why I have chosen this particular solution is that it's quite simple, but it has turned out to be very helpful. And it's also a good example of the flexibility and versatility of FME. But first, a short introduction to the project and the process of building tunnels, because I think you need it as background information for this presentation. Here's a map of Stockholm, and the metro extension is a giant ongoing underground project, just as Michael said. Here we have an overview with all the extended distances at different parts in different areas in Stockholm. And here we have 12 new stations with all their entrances. They are marked with a T here. And if you look at the upper right picture, you can see there will be several tunnels in this facility. In most cases, we have separate track tunnels for each direction for the trains, and then we have the service tunnels, and then we have the access tunnels, and then we have connection tunnels between all these tunnels. So And we have also vertical shafts for elevators and ventilation. So therefore, we will have many kilometers of new tunnels to take care of. And for those of you that haven't been to Sweden or have the knowledge of the geological conditions here, we have a very solid bedrock in most parts of the country. And so here in Stockholm. So therefore we need to blast our way through the rock to make our tunnels. So we're not drilling or boring any tunnels. And at the moment we have several parallel tunnel fronts at different locations in this network, if we see at this map here. And the plan is to be ready and run the trains in approximately 10 years from now. So we have a lot of things to do. And short about tunneling. At this slide, we can see a simplified workflow for blasting tunnels. First, holes are drilled in the tunnel front. And after that, we're loading the holes with explosive and connecting them to a trigger, you know, this classic thing, kaboom, and then we have the explosion. Finally, we need to remove all the loose rock from the front and also reinforce the new tunnel where it's necessary. And then we have the grouting. This is where FME comes into the picture. Before the blasting process starts all over again, we need to do some grouting for the next tunnel section. The basic principle for grouting is that the number of boreholes you can see on the left picture here are drilled in the rock for the next tunnel section like a screen. That's why we call it a screen. The boreholes are filled with grout, and the grout is normally a concrete mixture in this case. And the injection grout fills the cracks and the pores in the rock. And by doing this, we stabilize and seal the rock in the next tunnel section to control the flow of groundwater in the tunnel. Because we don't want leakage of water from the ceiling and the walls, and the groundwater needs to stay in the rock and in the surrounding ground. We also have very strict requirements from our authorities to keep the loss of water down under certain limits. And with the support of FME, we can keep an eye on the grouting process by controlling how much grout that has been injected and with which pressure and during which time span. And I ask you to please remember this picture you have here, especially the right one here. So keep it in mind. And to make a long story short, last spring, a colleague of mine, she's a rock specialist, she gave me a call and asked me if I could help her to visualize a couple of zipped text files to something readable. Okay, my answer was, of course, yes, I give it a try, I have FME. And these text files, they were the log file from the grouting machine. And as you can see here, we have some metadata in the beginning, and then we have time, pressure, flow, volume in different columns. That's quite easy. And she wanted something readable. And this is what she wanted, a diagram with a relation between the amount of injected grout compared to the flow and to the pressure. So we started testing in a small scale with some boreholes and find a solution worth working on. So here we are translating the log into the graph. Very easy task for FME. And we continued our work, and since we have different contractors at different locations, their equipment can vary between the different construction sites. So the log file doesn't look the same all the time if you get it from different grouting machines. And here we have an example from another contractor. It's an XML file on the right side with the same information as in the zipped text files on the left side. Therefore, we need to unify these two data sets in the workspace to make them work properly. And let's take a look at the schematic workflow for our solution. Here we can see on the left side, we're reading the log file from different formats. The file itself can be hard to interpret by only looking at them, especially the XML file, because it is good, it contains everything, but it's hard to understand it. But after doing some magic with FME, in the middle here, we can generate readable diagrams in different colors. So with FME, we make the data more available for those who need it. And here, finally, we have the workspace. I know that you have been waiting for this, but here it is. And as you can see here, I have two different readers on the left side. One for the text file on the bottom, and then you have the reader for the XML files on the top here. And to be completely honest with you, this workspace ain't rocket science, but it's very effective because we can handle lots of information from different data sources, very consequent. Therefore, we are saving lots of work and time in the project with this solution. The most tricky part here is actually to rearrange the table and keep all the attributes in correct order. And that is what we are doing here in the middle of the workspace. Because, you know, one borehole has a lot of information and one screen has a lot of boreholes, and the tunnel, all the tunnels we have, they have even more screens. So we will have lots of information, and the amount of data is increasing all the time when we are blasting our tunnels and grouting them. And we can handle all this information with this simple and reliable workspace. And let's take a look at the result here. Finally, we write each grouting screen to a separate X file. I made some tests in the beginning with the chart generator, but we wanted a more flexible solution. So that's why we started to use Excel instead. And on the first tab on the screenshot behind, we have the first sheet with an overview over all the boreholes in the screen, and they have their own separate small graph like a thumbnail. And for each borehole, then we have a separate tab with a diagram and table information for all each borehole in the screen. And as I said, this is based on an Excel template file from Excel, and it's empty in the beginning, and we've been working with that one quite a lot. That's one of the tricky part as well. The FME workspace, if you have the flow, you can just adjust in the Excel sheet. So this is where we can see all the information from the specific screen. And of course, we have had some challenges in this work as well. One thing that I've already mentioned is that we are working with different in-data sources and we need to harmonize them. Another thing is working with date and time, because we are interested in the relative time from the start to the end of the grouting. And I encountered some problems when the grouting started before and after ended after midnight. So we have this grouting process during 2 different days. And in that case, my tables and the graphs were divided into different sheets, and we had to work a little bit on that. But when we're talking FME, there's always a transformer that can help you. So in these 2 cases, I've been helped a lot by the attribute manager, one of my favorites. You can see here on the left side, I'm working with the attributes and naming, and my comments are in Swedish. Maybe you can read it and understand anyway. And then we have the date time calculator together with the date time converter. So they have been very helpful in this case. And here I'm trying to visualize my visions, because this is an ongoing project, and all this solution started as please, like a conversation over a telephone call. Please, can you help me with this? So it's like an ad hoc solution that we have been working on, and we are still developing it. And I can see a lot of potential in it, and we can probably speed up the working process, how we retrieve the data from the machine, from the grouting machine. So here I try to visualize like a machine connecting to some sort of cloud solution. You can upload and download the logs, and then you take it into FME, or maybe you can generate a chart or a diagram to an iPad or another smart device. I don't know. So I'm thinking about that. And as I told you, this solution is pretty new, and we're still working on it. And at the moment, we're running it only on desktop, actually. So I'm working on implementation in FME server. So it doesn't depend on me to doing it, just doing the evaluation of the data. And in the future, maybe we'll get in touch with other log formats from different machines, because they vary quite a lot, I think. Different machine, different manufacturers, different softwares in the machine. So we're working on this solution and improving it constantly. And this is my last slide, the conclusion. I think the second sentence here in this quote from my colleague Henrik says everything. The advantage with FME is that we can manage data uniformly regardless of the supplier. You can really feel the FME spirit in that sentence, don't you? And that's everything from me at the moment. I hope you like this presentation and that it can serve as inspiration to all of you out there. So do you have any questions or something?
Yeah. First of all, thank you, Ulf. Good presentation.
Thank you.
Mind-blowing.
Thank you very much.
Sorry. So our first some thoughts from me here, actually. This is non-geography, correct?
Yes, that's correct.
Yeah, and even though there is some positioning within the tunnels and the machines as well, this is non-geography. This is it's text file XML to Excel. Yeah, that's something that comes in my mind first of all. I've got some questions here regarding working with XML files. You mentioned favorite transformer with the time calculator, which also is my favorite transformer at the moment. But do you have any favorite transformers when working with XML?
Yeah, we can look at the workspace. It's in the beginning here. We have this. Oh, I don't know the name of it. Well, look at the workspace.
You mentioned have this attribute manager, but are you using like XML flattener or something?
Yeah, it's a flattener. I can find the name of it.
Yeah.
So you have it here in the beginning, but you're flattening it out and sorting it out all the information. So yeah.
That's
really my simple answer. Yeah.
That's the really good pro tip as well. So, and also I got a ping here from Dean. XML fragmenter is always also a good transformer when working.
Yeah, that's good.
I also recommend that to the audience here. Question regarding how was this done before FME? Was this a manual process? You took the log files and copy paste into Excel? Or
to be honest, I think it wasn't done at all, because I think someone told me, because we're a relatively new project, we started to blasting our tunnels last year, and I've heard some rumors that someone tried to copy paste the information from the different files and he made something in an Excel sheet, and that's why they liked Excel. So it's hard for me to answer that question. I don't think they've done anything sustainable anyway. So maybe they've been working with Excel. But people have experience from other infrastructure projects, and then they have this problem before, and they want to see something. So yeah, we have experience, but I think they're working quite a lot hands-on with Excel.
So it sounds like not only saving a lot of time, it's also enhancing the quality.
I hope so. I hope so, because we can control. Maybe we can look at this slide here where we have the graph, because we have this criterias when the grouting process should stop, because then we can control our contractors as well, because we have the contract. It says that you should inject grout to a certain amount of grout during under some pressure and during time and everything, so we can control the job they're doing actually. So we're hopefully saving time and money and maybe frustration. My colleagues, yeah.
FME, the frustration saver.
I hope so. I hope so.
Maybe something for Sigbjörn's Instagram. Yeah, but thank you so much, Ulf, for your presentation.
Thank you. The pleasure was on my side.
Yeah, thank you. So let's see. We will go on with the agenda for today. And I see now that Gabriel has turned his video on as well. So so welcome to the stage here, Gabriel.
Thank you very much.
I would like to make some kind of joke where you are raising data from the dead in PDFs, but I've done it so many times, so I don't think it's funny anymore. But I will actually tell a story when I first met you and how you inspired me to do what I'm doing now, 10 years later. It was in Germany, in Münster, an FME conference. I was brand new, both as an adult and as an employee at Sweco, but I was sitting down in the audience, and you were giving a speech around how to use Winamp with FME.
Yeah, that's true. To make playlists for MP3s in Winamp with FME. Yeah,
that was an eye opener for me. This is what I want to do. So, yeah, I haven't done anything with Winamp, but I've been working with FME, so you inspired me.
Thank you very much. It's a pleasure.
Yeah, so I will stop talking now and hand it over to you.
Yeah, thank you very much for having me here and to end this first of our sessions. And today's topic is called BIMify your PDFs. We thought that perhaps we should name it shit in, BIM out, but I think BIMify your PDFs are more polite way to say this. My name is Gabriel. Actually, I have the role of FME business developer and senior consultant at Sweco. I have all these fancy certificates that I like FME, but it's actually just a stamp that I'm a nerd. Yeah, I confess, I love FME, and I'm doing FME quite a lot, both on my professional side at Sweco, but also my private side, making playlists with FME or just managing my record collection with FME. Yeah, we can talk about that later. To start this presentation, I will ask you all to just reflect of this question. Do you know how many PDF documents that exist in the world? Of course, there's no true answer. There's nobody who actually knows. There's a PDF organization called that did an estimate in 2018 of how many PDF documents there actually exist in the world. And the answer is trillions of PDF files. But the most scary part is the next sentence, billions more PDF files every day, which means that we are even having more trillion of PDF files now, 3 years later. Hopefully one day I will go to one of the PDF conferences that this association have. It's going to be really nerdy, just talking about PDFs all day long. But we have trillions of PDF files. And PDFs have already overtaken religion. So if you go to Google and search, how do I convert to? And it populates the answer of the most recent or the most asked questions. PDF is way ahead of all the other religions, if you say PDF is a religion. That's quite interesting. And this is actually the case when working with property owners as well. property owners is those companies who build and manage and rent out property to clients. And they have been harvesting or gathering all these PDFs throughout the years, because every new project they build, every new house they build or construct, they say, okay, the requirements are that you need to hand in the drawings. There should be PDFs, which means they have huge archives of PDFs. And it has been really difficult to keep these PDFs up to date when they're remodeling the houses, which they do all of the time, because every client needs to have something else in their on their part of the house. And they understand that they need to start their digitalization journey somewhere. And they've heard that they need to work with BIM. They have perhaps not sure what BIM actually is, but they have a vision that it will be cost efficient and no errors, and they have full control of their buildings and assets. But what shall we do with all our PDFs? Shall we just throw them away? Are they an old legacy? And is it even possible to take a 2D PDF file and turn it into 3D BIM in some way? Is that even possible? And that was the question me and my colleagues got last year. Can we do something with this huge amount of PDFs? And of course, if the problem is PDF and the result should be IFC, the solution is of course FME. So yeah, we can do this, and I will walk you through the step-by-step how we did, and we will look at the result in the end. The steps taken are divided into actually 4 bigger steps. We need to start with extract a lot of metadata from the PDF files, and we need to calculate a scale, because the scale of the real world house compared to the scale on the drawing is quite tricky. It depends on the paper size of the PDF and which scale you set on your drawing. So we need to extract that, and then we need to find text. And we're working with raster PDFs here, so we use the Google Cloud Vision API, and I would talk about more about that later. Then we need to vectorize the rasters. We need to find walls and rooms, and we need to say to FME what is a wall and what is a room. And then we need to write everything as a 3D model. And we chose an IFC as a format, which is an open format and can be read in all the BIM software. And this workflow is put on as an FME server app. So it's actually just a creator, which we always call the part starter, that kicks one of the FME server job submit transformer alive. When that's finished, we go to the next part. And then in the end, we write an IFC file. So let's start with the metadata extraction and the first part of the scale factor. We read a lot of metadata from the PDF file with FME, with a normal PDF reader. But one of the things we need to take into account is the drawing a landscape or a portrait. And that is done with 2 of the format specific attributes that's incorporated in FME, the PDF page width and the PDF page height. So if the width is bigger than the height, then it's a landscape, and on the other way, it's a portrait. Then we need to start to calculate the scale. And the scale of the PDF is read as points. And we need to interpret these points into millimeters. And we go by the paper size. So if the points are in a certain amount, as you can see on the attribute range mapper, then it's a certain paper size. And that paper size has an actually width in millimeters in the real world. This is the first part of the scale factor. All of this metadata and information about the file and the drawing is stored in an FFS file. That's FME's own format, which is really fast and efficient for this task. So we store everything in an FFS file. So remember that. We have one FFS file right now. The next step is to identify the text and to do some more about the scale factor. And us FME nerds, when we try to solve a thing, we always tend to go to FME. And in FME, there's a tool called, there's a custom transformer called a tesseract. transformer, which is an open source library for doing OCR, the optical character recognition. But we found out that that one wasn't useful in this case. So we need something else. And SAFE has done some good work with wrapping FME around the Google AI services. So, and we put everything on the hub. So if you are in FME and you start to do Google Vision something, or just Google, then FME will advise you to download a package from the hub, which includes the Google Vision connector. And Google has done a lot of work on the OCR technology, which means we can use their solution. You need an API key, of course, as all these APIs does or require. But then we just send the raster input to Google and we retrieve a text output. That's easy. And all these texts, we need to find the scale, because all the drawings, they have a scale text that says, okay, is this 1 to 100 or 1 to 1000? And we're working with the metric side there, so we don't use foot or feet or inches. And then we do actually a quite easy regular expression, 1 colon and the numbers following. And now we have all the parts of the scale factor. We have, okay, which scale? Is it 1 to 100? Is the drawing done? We have which actually the page, the paper size of the PDF, and we have in which how many points the PDFs are in. And those 3 parts can be used to calculate the scale. So we can take the things we retrieve from the PDF and scale it to the correct millimeter size scale. All this information, all the text, of course, stored in an FFS file. So we have 2 FFS files now. The third part, which also is the biggest and hardest part, is the vectorization. We use a transformer that's commonly used by FME nerds, raster to polygon cursor, which extract raster cells and aggregate them or dissolve them to polygon based on their raster values. So we have a lot of polygons, we have a lot of areas. Now we need to find walls and rooms. But how can FME separate a wall from a room? They could be really thick walls, or they can also be very small rooms. Then we have in our FME server app, when we run this, we have a parameter which the user can set. How small is the smallest room? And that is one of the threshold values that we use in FME to filter out everything that's smaller than this threshold value can't be a room. There's something else. And we also consider the shape of the geometry, not the type, because everything is areas, but the shape. Rooms are often rectangles, 4-sided. Not always the case, I know, but sometimes it is, and we use this as one of the parts when we try to extract if is it a wall or a room. And actually this is made, a lot of work is made to the center line replacer transformer, and a lot of trial and errors, because when we tried and to develop this solution, we saw that all of the PDFs we try, you learn a bit. For every PDF you try, you see something else you need to consider and take care of. So now we have a lot of areas, and they are hopefully divided into rooms and walls, and everything is stored in FFS files. So now we have 3 FFS files. So time to construct a 3D model. We have the metadata and scale factors. We have the texts, we have the rooms, we have the walls. We also have input from the user when they start this app or this workflow. We have some information about how the height from the floor to the ceiling. That information is used to extrude all the walls and the rooms to 3D. We can set room name and ID to the rooms, and the rooms are actually a volume that's surrounded by walls. We scale everything to the right scale in millimeters, because that's what the architects like to work with. And we can also set the house name and ID and everything else that is read from the drawing stamp could be retrieved as text and set as metadata. and we write everything to IFC. So why have we chosen IFC as an output format? Well, IFC is commonly used as it's an open format, and it's commonly used as view-only format, or something to view and look at. And a lot of our customers also use IFC to retrieve information and put in their facility management software. So we tried IFC. It's a pretty complicated format. It's one of the most complicated format I've tried. It's a hierarchical format, so you need to set how the geometries you write, how they relate to each other. If you're writing a room, you must say, okay, this room is on this story on the building, and it's in this building, and the building is on this site, and this process is done with the geometry property setter transformer. Then we have a lot of attributes like the room name and ID. We need to store those information as attributes. And in the IFC world, they talk about attributes as property sets. And those property sets needs to be defined in the correct way in the IFC file. And SAFE have done a good job to give us a transformer that helps us, called the IFC property set definition creator. I guess one of the longest names, which help us convert the attributes into the definition of the property set. We then can use the attributes to set on each geometry. One thing to say about the rooms, that the rooms, if you look at it in real world, the room, well, of course there are walls and there are ceiling and there's floor, but there's nothing called a room. But in the IFC world, there's an object called IFC space. It's like a, would you say, some sort of object that just box in the room, and that object is really good for calculating the building area and the area for the rentable areas. And we also write that geometry type into the IFC file. So let's see how this looks like. Unfortunately, I only have screenshots because I don't want to do this live. You never know what's going to happen. So we build an app. So the user has just an app. So when they find a PDF file that they want to do they want to convert to IFC, they go to this FME server app. They input your PDF file, say which floor number is it, which floor height from the floor to the ceiling in millimeters, and which is the threshold value for the smallest room to find. And we're going to look at this drawing. As you see, there's a lot of background noise here. There's a lot of dashed and dotted lines. There are text all over the place. The human eye can quite easily interpret where the rooms are and hopefully where the walls are. But as you can see, there's a lot of other things going on in this drawing. And I've highlighted a room that zoomed out. It's a conference room in Swedish. It's the room number is 769, and it's for 12 persons. So we will see if we can try to retrieve this room and the information that's stored on this drawing with FME. And the result looks like this in the FME Data Inspector. The brown are the walls. The other colored things are the IFC space objects, but I just randomly colored in some random way. And the red ones are the conference rooms. So, and of course, it's in 3D. And if we have highlighted one of the rooms here, and we can look down here on the right, we have those attributes which I talked about. They are transferred to property sets, and FME read them as traits, which means that we can retrieve them back into the workflow if we read the IFC file. And if you just zoom in, we see that the type is a conference room for 12 persons, and the number is 769, and it's a room. And we have the opportunity, of course, to tell which material it is or whatever. So some conclusions about the work, or the process of the work. The input much controls the quality of the result. And we have tried to group this into 4 different categories. If you have a hand-drawn drawing from the 60s, which has been used and then scanned, and which is actually quite common, then FME can produce spaghetti for you. It's really hard to use. There's a lot of lines going on. It's really hard to like group things together as objects. If you have something that is CAD drawn from the start, but somewhere in the process printed, used and then scanned back into a PDF or another raster file format, the result could be okay. It depends on the paper. How much have you folded it? If you put your coffee cup on the drawing, which we have seen, then FME will create a round room for you there. So it depends on the paper quality. If you have something that is CAD drawn but saved as a raster file, which is the case that we have investigated, the result is it's good. It's not perfect, but it's good for further use or to get a hint of what am I looking at. If the input data is a CAD drawn and is saved as a vector PDF, of course the result is better. We can retrieve the actual geometries and construct a lot of things better. But hey, it's always nice to have the worst data to try to do some magic with. So that's about it, Michael. Do we have any questions or something?
Yeah, got some questions here. One concerning doors. I guess you can apply it to other objects as well. Do you have any? Have you found any doors?
We found doors, yeah.
Yeah.
The tricky part is to how can we separate the wall from the door? And are all the doors look the same? They need to like teach FME more. It's more common like machine learning. How is the geometry look like when it's a door? But then we have doors that are turned to the left or to the right or in or out from a room, and it could be drawn in many different ways. So it's hard. We've done some testing. We can retrieve some of the doors, but as we couldn't retrieve all the doors, we took them away. And the same goes with the water closet, the toilet seat, and the washing bins. We can find them if they are done in the same way on the same drawings. But it's hard, yeah.
Have to convince the architects just to use toilets in one direction.
Yeah, well, it's we always come back to that. You have your CAD standards. How well does the constructor or the architects follow them? And have you done some validation of the deliveries that the architects hand in? Have you done it with FME? Can you find that they've used the same block all over? So yeah.
A question about the performance as well here. When you put a PDF like that you showed within the app, how long time does it take?
Oh, it depends on actually the machine we're running it on. We have right now a single engine. I think it's actually a virtual machine in our environment. It takes a couple of minutes. It does. I think we could ramp up the speed quite a bit if you put it on FME Cloud. And that's also how does the client want to run this? Do we want to run all of the PDF files in once, the whole archives? Then we have done it in the other way. Now they run it on demand, and then perhaps it's okay to wait a few minutes.
Yeah, I guess you're saving a lot of time either way with this.
Yeah, but there is the other way. The solution to use the PDF is to have them as a background and then draw manually all the things. Of course, our result can be used for that as well. So, but yeah, you get a hint of what actually you're looking at in 3D.
Yeah.
Any more questions?
Not at the moment, I think. Yeah, there. About the Google the API. Is it expensive?
Nope.
No.
Actually, I wrote when we did this investigation of the Google AI services package for FME was just released when we tried this out. I think it was actually in a beta FME 2020, and ask a question in knowledge base. How does this work for the amounts and the costs and everything? And there's a good article if on the SAFE community if you search for Google Vision. I think Gerhard has answered me, and it's not expensive. You have to go a huge amount of requests to get expensive.
Yeah. Great. That's all for the questions there.
Yep.
Thank you so much, Gabriel.
You're
really
welcome.
Good presentation. Could Josephine share oh, there we have it, the upcoming sessions. So we will go on in Monday with some Dutch presentations, and then at Tuesday and Wednesday we will proceed the Traveling Data Fair of Scandinavia. So there will be some presentations in Swedish, Norwegian, and Danish those days. And we will end up, you and me, Gabriel, the last day there with some fun way of hacking FME stuff, not so very seriously, but I think it was really a great last hour of the FME World Fair from Sweco here. Yeah, and if you would like to stay in this meeting, we will have it open a little while here. So if you want just to chat, or yeah, you know, the regular conference mingling, we could just stay around within the Zoom meeting here, until 12 a.m. here. But for all you guys turning off your meeting now, thank you so much for listening in, and have a nice weekend. Thank you.